Hey students, so the next topic is ball and stick model. Okay, the ball represents atoms, the stick represents the chemical bond between the atoms. Balls that are different color represent atoms of different elements, and the element that each color represents is shown in the legend. So basically, in these models, balls represent atoms and stick represent the chemical bond that holding them together. Different colors show different elements. Okay? So every element has its own abbreviation called its atomic symbol. Every chemical element is represented by its own symbol. For some elements, that symbol is in one capital letter, and for other elements, it is one capital letter followed by one lowercase letter. For example, the symbol for the element boron is B, and the symbol for the element chlorine is Cl. The molecule shown above has one boron atom and three chlorine atoms. A chemical bond links each chlorine atoms to the boron atom. So basically, we're saying that every element has one or two letter nickname, which is you can say atomic symbol, like B for boron and Cl for chlorine. Okay, look at this picture. Like the picture shows a molecule made of one boron atom bonded by three chlorine atoms. Okay. So the next topic is classification of elements and compounds. Okay. There are more than 100 different chemical elements or types of atoms. Chemical elements make up all of the substance around you. So basically, we are saying that there are more than 100 different chemical elements. You can say types of atoms in the world, and everything around you is made from combination of these elements. Okay, so elements, substance that are composed of only one chemical element are elementary substances. So, elementary substances are basically made of only one type of chemical element, okay? And compounds, substances that are composed of multiple chemical elements bonded together are compounds. So, basically, compounds are made of multiple different chemical elements bonded together, okay? So, every chemical element is represented by its own atomic symbol. An atomic symbol may consist of one capital letter or it may consist of a capital letter followed by a lowercase letter. Okay, so every element has a unique symbol. It is always either one capital letter like fluorine, which is F, or a capital letter followed by a lowercase letter. Okay, like beryllium, you can say, which is Be. Okay, these symbols are what we use to write out chemical formulas. Okay, so the atomic symbol for each chemical element in a substance is shown in the substance chemical formula. Okay, these symbols are what we use to write out chemical formulas. Okay, so, chemical formulas for elements. Okay. An elementary substance is represented by a chemical formula that contains only one atomic symbol. The atomic symbol in a chemical formula may be followed by a small number written lower than the symbol. Okay. This number is called a subscript. So basically, formulas for elementary substances only have one atomic symbol. Okay, and what are subscript? Like the small number written at the bottom right of a symbol tells you how many atoms are bonded together. Okay, for example, O2 means that there are two oxygen atoms bonded together. Okay, a subscript is included when the atoms in the elementary substances are bonded to form molecules. The subscript shows how many atoms are in each molecule. So, as I have told you, the easy definition of subscript, like the small number written at the bottom right of a symbol, tells you how many atoms are bonded together. Okay, so for example, chemical formula for the elementary substance oxygen O2, which I have discussed, has a subscript of 2, which means that the atomic symbol O represents two atoms. Okay? The elementary substance O2 and the chemical element represented by the atomic symbol O are both named oxygen. So the formula tells you that each molecule of O2 contains two oxygen atoms. Okay? So, chemical formulas for compounds. Okay. A compound is represented by a chemical formula that contains multiple atomic symbols. The chemical elements in a compound are bonded together in a fixed ratio. This ratio is shown in a compound's chemical formula. So basically, we're saying that because compounds are made of different elements, as I have told you. So their formulas will have multiple atomic symbols mixed together in a fixed ratio. Okay? In simple words, that compounds are made of different elements and their formulas will have multiple atomic symbols mixed together in a fixed ratio. Okay? For example, beryllium fluoride is BeF2. Okay? This means for every one beryllium atom, which no numbers means one, okay, there are exactly two fluorine atoms, okay. Read this example so that you can understand it more easily. Like in the compound beryllium fluoride, there is one beryllium atom for every two fluorine atoms. So the ratio of beryllium atoms to fluorine atom is 1 to 2. This ratio is shown in the chemical formula for beryllium fluoride, which is BeF2. There is no subscript following the atomic symbol Be because that symbol represents one atom. The subscript 2 follows the atomic symbol F to show that the symbol represents two atoms. Okay? So, you can tell whether oxygen is an elementary substance or compound by counting the number of atoms and number of atomic symbols in its chemical formula. An atomic symbol consists of either one capital letter or a capital letter followed by one or two lowercase letter. The chemical formula for oxygen O2 contain one atomic symbol O. So the formula tells you that oxygen is composed of only one chemical element. Since oxygen is composed of only one chemical element, oxygen is an elementary substance. In simple words, that you can tell if something is an element or a compound just by counting the capital letters in its formula. Since O2 only has one atomic symbol, O. Oxygen is an elementary substance, not a compound. Okay? So, okay. So, ball and stick models. Scientists use different types of models is represent substance whose atoms are bonded in different ways. One type of model is ball and stick model. As I have told you in the previous slides, the ball and stick model represents a molecule of the compound boron trichloride. Okay? So, So use the model to determine whether methanol is an elementary substance or a compound. Okay, so basically this is a practice problem to see if methanol is an element or a compound. Okay, in the ball and stick model shown above, each ball is light gray, red or dark gray. Okay, use the legend to determine the chemical element represented by each color. The colors and atomic symbols from the legend are shown in the table below. This one. Okay. So the table also includes the name of the chemical elements represented in the model. Like step one is this, that to look at the model's color. By checking the color key legend, we find that methanol contains hydrogen, which is gray, carbon, which is dark gray, and oxygen, which is red. Okay, look at this example. You can see from the model that a molecule of methanol is composed of four hydrogen atoms, one carbon atom, and one oxygen atom bonded together, which is four hydrogen atom. This one is carbon atom, and sorry, this one is oxygen atom, and this one is carbon atom. Okay. Determine whether the substance is an elementary substance or a compound. You know from step one that methanol is composed of three chemical elements, which is hydrogen, carbon, and oxygen. Since methanol is composed of multiple chemical elements bonded together, which is methanol is a compound. So basically, because methanol is made of three different elements bonded together instead of just one, so methanol is a compound.